different cases of dipole. Suppose that first of all we are taking the case number 1 first. In case 1, your dipole is placed in the direction of the electric field. This is the dipole. Of minus q charge and the plus q charge. This is the direction of the dipole. And the field is also in the same direction. So we can say here the angle between the dipole and electric field is 0 degree. If the angle between them is 0, then what will be the net force acting upon this body? Then the net force also be 0. If the net force is 0, then we can say the body is in translational equilibrium. Translational equilibrium. And what will be the torque acting upon the system? The torque will be tau is equal to Rf sine theta. Sine theta is your sine 0. Rf sine 0. And finally you get the net torque acting upon the body is also 0. If the net torque is 0, then we can also say body is in also rotational equilibrium. All right. Are you clear or not? And in this case, the torque will be minimum. The value of torque is minimum. In the second case, we are taking the dipole in the field perpendicular to, we are taking the dipole perpendicular to the field. This is the dipole. This is the dipole of minus q and plus q charge, and your field is acting perpendicular to the dipole. The dipole is in this direction, and this is your field direction. Then, can you tell me what will be the angle between the dipole and the field? It is theta is equal to 90 degree. If the theta is 90, then we can write here the net force acting upon the body. What will be the net force acting upon the body? Net force also be 0. F net is again 0. Whereas what will be the torque? Tau is equal to Rf sine 90 degree. And sine 90 is 1. So we can write here tau is equal to R into F. This is the value of the torque. This is the value of the torque in this case number 2. Finally, we can say this is the torque acting upon the body is maximum. So we can write here tau max is equal to R into F. Okay. And finally, there is not in rotational equilibrium. Okay. System is not in rotational equilibrium. Note it down, please. And the case number 3. What will happen when your dipole is placed in the field in opposite to the direction of field? This is your field E, and this is your minus of q charge, and this one is the plus q charge. The direction of the dipole is this. Okay. Here theta is equal to 180 degree. Net force once again is 0. Once again the net force is 0. And tau, what is the torque? Tau is equal to Rf sine 180. Sine 180 is also 0. Finally, you get tau is equal to 0. Okay. Once again, your torque is minimum. Please note it down, all of these 3 cases. Can we move on?
Yes.
Hello.
Yes, sir.
Okay. Now torque is over. Okay. I mean dipole is over. And now we are going to start a new topic of Gauss law. Before the study of Gauss law, first of all, we will discuss about the area vector. All of you are knowing about the area vector? The area vector. What is the area vector? If this is an area of S, then the direction of this area vector will be perpendicular to the surface. So this area vector can be written as S of N. This is your magnitude actually. All right. So please note it down and write here the direction is outwards normal. Okay. Direction is outward normal. Okay. This is your area vector. Next is electric flux. What is the electric flux? Any one of you? Electric flux is the number of field lines crossing area normally. Are you clear or not? Suppose that you have a cross-sectional area like this. Sorry, you have an area like this. Then there are total then the total number of lines passing is 3. Then you can say that the flux of this area is 3. Are you clear or not? So electric flux is the measure of number of field lines crossing perpendicularly, or you can say crossing normally. Are you clear or not? Note it down, please. All of you have noted it. Hello.
Yes, sir.
That's
Okay. Now, when your area is plane, I mean your surface is plane, you can say suppose that your surface is plane. Then you can write here for plane surface. This is your surface. This is your surface. And in this case, the normal vector, suppose that the electric field is passing through this surface at some particular angle, theta, from the normal. All right? At some particular angle, theta, from the normal. Then we can write here, this is your angle theta. This is the direction of electric field line, which is passing at some particular angle theta from the normal. Okay, this is your area vector S dash. Then can you tell me what will be the what will be the value of the flux? In this case, you can write here for first electric field, electric field E, electric field E is inclined at theta angle with respect to area vector. Then we can write here phi is equal to E dot S. What is the E dot S? There is the angle between E dot S is theta. So we can write also phi is equal to ES cos theta. This is your flux passing through this area S. It is a scalar quantity. Okay. And the unit is electric field. Unit of electric field is Newton meter square. Area is your Newton meter square per coulomb. This is your unit in SI system. All right. Note it down, please. Sometimes it is also written as like voltmeter. Voltmeter is also the another unit of electric flux. Note it down, please. Have you noted it? Hello?
Yes, sir.
Okay. Let's try to solve a question here. Electric field. One second. Electric field E is equal to I plus 2J plus 3K Newton per coulomb exists in space. Calculate flux through area S, which is I minus 2J plus K meter square. Okay, this is your question. Let's try to solve it. What will be the solution? There are total two variables are given. The first one is the I. First one is the electric field, which is I plus 2J plus 3K Newton per coulomb, and S is of I minus 2J plus K meter square. Then what will be the flux? The value of flux is vector of E dot vector S, which is equal to, what is the value of E? You can write here I plus 2J plus 3K, and S is I minus 2J plus k. I and I. Okay, remember here the same type of unit vector will multiply here. When I will multiply with I, then you got 1. 2j and minus 2j will be minus of 4j plus 3k and 1k will be 3. 1 second, sorry. It is not j. J will be 1. Minus of 4 and 3k, 1k will be 3. It is 1 minus 4 plus 3. Finally, you got phi is equal to 0. I mean the net flux through this area due to this electric field is 0. Are you clear? Are you clear or not?
Yes. Yes, sir.
Yeah. Note it down, please. All of you remember such types of multiplication from your previous class 11? All of you remember till now this
Yes,
method
yes,
of
sir.
multiplication of the vector? Hello?
Yes, sir. You said yes.
Yeah, all right, good. Note it down, please. Have you noted it? Hello?
Yes.
Okay. Next question. Note it down, please. Electric field vector E is equal to I plus 2j plus 3k Newton per coulomb exists in space. Calculate flux through area of 3 meter square in XY plane. Note it down and try to solve yourself. All of you can solve it or not?
Sir, is it 9?
Yes, good.
Thanks.
And Zarsh,
Yes, sir.
yeah, what is your answer? Zarsh, Nawal. What is your answer? Zarsh, Nawal. See on the screen, please. The value of E, which is given as I plus 2J plus 3K Newton per Coulomb. And area vector is given in XY plane. You have already know this is your X and this is your Y. What is the XY plane? This is your plane. Okay, this is your plane. Then can you tell me if this is your plane, then what will be the direction of the area vector? I think the direction of area vector will be perpendicular to this plane. I mean along Z axis. Are you understand it or not? Zarsh,
Yes, sir.
Nawal, Matthew, all of you understanding or not?
Yes.
This is the plane of XY plane. Okay. And we know the area vector is always perpendicular to the plane. Or you can also say it always be normal to the plane. Okay. And if you try to draw the normal from this plane, then you will be in the direction of the Z axis. Hence, we can write here the value of S is, I mean S vector is 3 K cap meter square. Are you understand it or not? What will be the final
Understood.
calculation? Phi is equal to E dot S, your I, 2J, 3K. And for S, we can write here 0I, 0J plus 3K. Am I right or not? When you multiply I and J with another bracket of I and J, you get 0 plus 0 and 3K and 3K will be 9. Finally, you get 9. Okay. Note it down, please. This is your final answer. Have you noted it?
Yes, sir.
Okay. Next. The next is when your surface is curved, for curved surface. Or you can also write here or non-uniform electric field. Non-uniform electric field. When your field is non-uniform, in this case, suppose that this is your diagram. Okay, this is your diagram and the area is S. Some field lines are passing like this. Okay, these are the electric field line passing through this surface. Then can you tell me what will be the normal at this position? You have already known normal always makes 90 degree from the surface. If you take this small area of ds, then the normal will be along this direction. Okay, just similarly, the normal for this point is also same. Sorry, not same. This is along this direction, and for this it will be another theta. It may be another theta. All of these are the unit vector. Area vector of ds. We are taking a small area ds. Then first of all, we are writing here, consider any small area. Consider a small area element ds vector. Then the flux of this small area will be d phi, which is equal to the E dot ds. To calculate total flux throughout this curved surface area, we should integrate it. Then we can write here, total flux will be, for total flux, we are going to integrate it. D phi is equal to integration of E dot ds. Okay, this is your this is your surface integral especially. So we can write here as S. Finally, after integrating, you got phi is equal to integration of E dot ds. Okay, you can write here as S because you are taking the integration with respect to area S. Okay, if your surface is closed, for closed surface area, for closed surface, for closed surface like sphere, cylinder, cube, all of these surfaces are closed. Cube, cuboid, etc. You can write here flux phi is equal to integration. Okay, after writing your integral sign, you can draw a circle at the center like this. Okay, this circle denotes that the integration are taken with respect to a closed area. Are you understand it or not? E into ds. Are you clear? This circle represents closed surface area. Okay, note it down, please. Have you noted it? Hello?
Yes, sir.
Okay. Next. We are taking a question here. Note it down. Electric field of 10 Newton per Coulomb. Electric field of 10 Newton per Coulomb exists in space. Calculate flux through an area of 2 meters square. If field lines are inclined at 30 degree with the plane of area. Note it down, please. Have you noted it?
Yes, sir.
All of you can solve it or not? This is a very easy question.
So we need to use EDS cos theta, right?
Sorry,
We need to use EDS cos theta, right?
exactly. EDS, or you can take as S because your area is fixed here. Okay, I mean finite.
Yes, sir.
Are you clear? So we can write here ES cos theta. The value of E is your 10, S is your 2 meter square, and theta is 30 degree, I think. No. Field lines are inclined at theta. Cos theta sine 31/2. Field exists in space. Calculate the flux to an area of 2 meters square. The field lines are inclined at 30 degree. 1 second, just 1 second. Give me 1 second, please. Cos. Yeah, cos of 30 you can place here. And finally, you got the answer. Okay. Next question. Note it down fast. This is a very important question. You can write here important for the board. A charge Q is placed at the center of a sphere of radius r. Calculate electric flux through the sphere. Calculate electric flux through the sphere. Are you clear or not? Note it down and try to understand here. It is saying that a charge Q is placed at the center of a sphere. First of all, we are going to draw the diagram. This is your sphere. And it's saying that a charge Q is placed at the center. This is the center of the sphere. The charge placed is capital Q. Okay. Saying that calculate electric flux through this sphere. And now you can imagine that if this charge Q is placed inside this sphere, then we can say here there are infinitely many field lines are passing through this area. Am I right or not? Hello? There are infinitely many field lines are passing. Are you clear? Just like this. Are you clear or not?
Yes.
Yes.
I mean, the amount of field lines, we can't count it algebraically. Are you clear? So first of all, if there are infinitely many field lines are passing through this area, then we are going to take only one field lines. Okay. Suppose this field lines is of E, and the unit vector from this area, you can take it as area ds. The unit vector is like this. I mean, in the same direction. Okay. The angle between E and area vector is 0. So first we are going to calculate the flux for this area ds. Okay. For this area ds. Flux through the surface ds. It will be phi is equal to integration of E dot ds. Are you clear? And what is the angle between them? For the angle you can take as cos of 0 degree. Finally, you get phi is equal to E dot ds integration of. Okay. And now we have already know the electric field. The value of electric field at this point is kq over upon r square. So we can write here. We can write here as the value of, one second, I'm going to do it directly here. We can write here phi is equal to integration of kq. The radius of this is r. You can take at kq over r square ds. Okay. ds is this small area. This is infinitesimally small. You can imagine it just like a point size. Okay. Finally, kq over r square can be taken outside from the integral into ds. When you integrate it, just ds, when you integrate it, you get the total area of S. And what is the total area of S? You have already know the area of the sphere is 4 pi r square. One second, I am going to again writing here value of k in detail. 1 over 4 pi epsilon naught q over r square, and the value of S is 4 pi r square. 4 pi r square can be cancelled from 4 pi r square. Finally, you get phi is equal to q over epsilon naught. This is the amount of flux passing through this area S. Okay. Are you understand it or not? Hello.
Yes, sir.
Yes, sir.
Nawal, Zarsh, all of you have understanding.
Yeah.
Is there any confusion in this solution? Because it is very, very important derivation for your for your board point of view. Okay. So if all of you have any type of confusion, you can, okay, feel free to ask me. Tell me, please, is there any issues in this solution?
No, sir.
Okay, good. So please note it down first.
एग्जाम की डेट आई है
Have you noted it?
Yes, sir.
Yes.
Okay. Next. Now, the next point is Gauss law, which is very, very important law. Gauss law. Any one of you can tell me what is the Gauss law in actual? Any one of you? Nawal, Zarsh, and
Gauss Law states
Matthew.
that the total electric charge within
Sorry?
surface, total electric charge within a surface is equal to.
No. I just want to ask you, what is the role of the Gauss law? What is the significance of the Gauss law?
To calculate electric flux.
Remember that Gauss law gives you a short method or shortcut to calculate the field directly from the charge. Are you clear or not?
Okay, sir.
This gives you a shortcut method to calculate the field from the charge. Are you clear? Like, suppose that you have a charge Q. Then can you calculate the electric field? We have already know the formula of electric field. Sorry, these are the two charges. Okay. Then what will be the electric field? First of all, you will go to calculate the force acting between the charge. Then you can apply the field E is equal to F over Q. Are you clear or not? And we get the electric field. But Gauss law, without any requirement to calculate the force, okay, from the help of Gauss law, without go on the calculation of force, you can calculate the electric field. Are you clear or not? This is one of the short method to calculate the field. Are you clear? So please write down. You are going to understand it. Write down, please. Electric flux through closed surface is 1/epsilon naught times of total charge enclosed by the surface. Suppose that you have a charge like this. This charge is enclosed through this area. Then the flux is your integration of E dot ds, which is equal to the Q enclosed over epsilon naught. Note it down, please. Have you noted it? Hello?
Yes, sir.
Have you noted it?
Yes.
Now, the properties. What are the properties of Gauss law? Properties of Gauss law. The first law is saying that it is independent on the shape. One second. It is independent of shape and size of the surface. Okay? I mean, no matter what is the shape and size, or you can say the configuration of the surface. Suppose that this type of configuration, or you can take it like this configuration. Okay? Or you can also take it like this configuration. For all of these type of configuration, you can write here, if the charge Q is enclosed at the center, okay, then you can write here phi is equal to Q over epsilon naught. Phi is equal to Q over epsilon naught. This is your, sorry, just one second, please. Q enclosed, you can write here, Q enclosed over epsilon naught. Phi is equal to Q enclosed over epsilon naught. If you can take, suppose you are taking a large size of sphere and the radius of this is of 2r, then once again your flux will be same. I mean Q enclosed upon epsilon naught. Are you clear or not? Hence we can say that it doesn't depend on the shape and size of the surface. Note it down, please. Have you noted it?
Yes, sir.
Okay. All of you are understanding clearly?
Yes.
Good. And now, suppose that the charge enclosed within the surface is positive. Okay. Then the flux is always, flux in the sense the field lines are always going away from the charge. In such a case, we can say that your flux always be positive. So write down here, outwards flux is positive. You can write phi is equal to Q enclosed upon epsilon naught plus. Okay. Similarly, if you have taken a like negative charge, then the field lines are behaving like a sink. Okay. You can say as it sink charge also. Okay. So inward flux. This is your inward flux. Inward flux is negative. You can write phi is equal to minus of Q enclosed over epsilon naught. Note it down fast. Have you noted it? Hello.
Yes.
Good. Third point. Suppose that you have an area of like this. Okay. And the field lines are passing through this area 2 times. 2 times in the sense in such a way. 2 times. Then can you tell me what will be the net flux? You can say here for this area, okay, for this part of area, the flux is inward. Are you clear or not?
Yes.
And for this region, your flux is outward. Okay. Hence, we can say the flux in is equal to flux out. Are you understand it or not? I mean,
Yes.
net inward flux is equal to the net outward flux. You can write here net inward flux. Net inward flux is equal to the net outward flux. Are you clear? Hence, we can say, one second. Inward flux is equal to outward flux. So we can say the net flux is equal to 0. Finally, we can write here in electric, if electric field lines, are crossing a closed surface, then the phi is equal to 0. Okay. Note it down, please. Similarly, this is your point number 4. Suppose that you have 3 charges. One of them is Q1 and the another one is of Q2 The third one is of Q3, which is placed outside of the closed surface. Then remember that the net field generating from the Q3 will enter at once and also go outward from this surface. Finally, we can say the net flux through the charge Q3 will be 0, or you can also say the charge outside the closed surface will not contribute to the flux. Okay. Finally, we can write here phi is equal to Q enclosed over epsilon naught, which is equal to the plus of Q1. Total amount of charge enclosed, Q1 and Q2. So we can write here Q1 and Q2 plus epsilon naught. This is your final answer. Are you clear?
Yes.
Note down, please. Have you noted it?
Yes.
Good. Point number 5. Suppose that a dipole is placed inside this surface. What will happen if a dipole is placed inside this? This is your of plus Q charge and this is of minus Q charge. For the dipole, we have already know this is the combination of two equal and opposite charge. Am I right or not? All of you remember about the definition of dipole?
Yeah.
What is the condition of the dipole? The both of the charges should be equal in magnitude, but opposite in nature. Okay. So we can tell us here that the amount of field lines leaving this surface due to plus Q charge will be equal to the amount of field lines entering to this surface. Are you clear? Hence, we can say the net charge, the net flux through this area is 0. Right there. If electric dipole is enclosed by a surface, then phi is equal to Q enclosed over epsilon naught, which is equal to Q minus Q over epsilon naught. Finally, 0. You can write flux as 0. Note it down, please. Have you noted it? Good. Now, we are taking a question. a charge Q is placed at the center of hemisphere as shown in figure. Calculate flux through the hemisphere. All right. Calculate flux through the hemisphere. Can you solve it? Any one of you? This is the hemisphere. This is a hemisphere. Okay. And what it is saying that this is your hemisphere. It is saying that calculate the flux passing through this hemisphere. Suppose that your charge is placed at this position of Q. This is your positive charge. And now can you calculate it? Hello? You can calculate it?
I guess.
Yeah. For such type of question, we have already know if the surface is closed and the charge is placed inside the surface, then the flux is Q over epsilon naught. Are you clear or not? Okay.
Sir.
So for solving such type of question, we are going to add the another hemisphere in this, in such a way that if we add it, then we can say that now this hemisphere becomes a sphere. Am I right or not? Are you clear?
Yes.
Then what will happen? First of all, we have added here one more hemisphere. Then we can write here the flux through. And now can you tell me how many hemispheres are available right now? There are two hemispheres right now. Flux through two hemispheres is Q over epsilon naught. Are you understand it or not? We can write a sphere, or one sphere can be seen like a two hemisphere. Are you understand it?
Yes.
So we can write here the flux through one hemisphere will be equal to Q over 2 epsilon naught. This is your final answer. Are you clear? Are you understand it?
Yes.
Now we have get the value of flux for this hemisphere. Are you clear? So for doing such type of question, you should add the same type of the configuration, same type of the shape, okay, to close it. By doing this, you can solve it easily. Note it down, please. Have you noted it?
Yes, sir.
Good. Another question. A charge Q is placed at a separation a/2 from the center. From the center of a square of each side A calculate flux through the square. Note it down, please, and draw this diagram. Note it down, please.
Yes, sir.
This is your square of side A. Side A. There is a point of charge Q. There is a charge of Q. And now it is saying that calculate the flux through this square. Note it down, please. And try to solve by yourself. Have you noted it? Hello, Zarsh, Nawal. All of you can solve it or not? Can you solve it or not?
Sir, can you do it?
Not possible. Okay. Now this is if we try to understand it in a way that 1 second. This is your a/2. You can understand it like this. This is a face of a cube. Okay. If you are considering a face of a cube, Then can you tell me how many faces are possible in a cube?
6.
Total 6 faces. Then what will happen if we make it total 5 faces? What will happen? You can make it total 5 faces like this. This is your one face. Are you clear? This is your one
Okay.
face. And this one is your another face. How many faces are now? There are total 2 faces.
3.
Sorry, 3.
Yeah, 3.
Yeah. Leaving. 1 second. Now it is total 6.
Yes.
This one is the first. It is your 2, 3, 4, 5, and 6. Are you clear or not? Are you understand it?
Yes, sir.
Yeah, there are total 6 faces. Now we can say that when we add 5 more squares, we get a cube. Then can you tell me flux through cube is q over epsilon naught? Or we can also write it the same value in another way. Flux, 1 second, sorry. Flux through 6 faces. Can we write 1 cube is equal to 6 faces or not?
Yes.
Okay, 6 face is equal to q over epsilon naught. Then the flux through 1 face is equal to 1 by 6 into q over epsilon naught. This is your final answer. Are you clear?
Yes.
All of you have understand it?
Yes.
Zash, Nawal,
Yes, sir.
is there any issue?
No, sir.
Okay, good, good. Note it down, please. All of you have noted it or not?
Noted.
Yes.
All right, good. And now I am going to write a question for your homework. Okay. Please note it down. We have a question like electric field Ex is equal to alpha of x to the power 1 by 2. Ey is equal to 0. And Ez is equal to 0. Exist in space. Calculate flux through the charge enclosed by the cube. Note it down, please. Okay. This is your NCERT question. You can take the help from your NCERT book. Okay. And we will discuss about it in the next class. Are you clear?
Okay, sir.
Yeah. Note it down, please, all of you.
So in this, it's an XYZ plane, right?
Yeah. XYZ plane. A cube is placed in XYZ plane. Okay. It is very simple question. And tomorrow we will also try to solve one another question which is also from your NCERT. Then we will start applying